And if you didn't do the homework, then that's not my problem. All right. So with that being said, we're going into 5.6. Now, I can tell you right now, I would say pretty much 80% of your test is going to be from 5.3 and 5.6.
I'm here. I'm late.
I'm sorry, what?
I'm here. I'm a minute late. I was with my other teacher looking at something.
That's all right. I haven't taken roll yet.
Okay.
In fact, well, yeah, I have. I gave everybody a here today, and I need y'all to mute your mic. I gave everybody a here today because everybody was working on homework like yesterday. So I went through and gave everybody a here today. So I don't have to do attendance today because I went through and gave everybody a here, because everybody comes except for a couple of people and they're working, and that's why they can't come every day. So I'm glad Mr. Ferguson's here today. Glad to have you, Mr. Ferguson. And I got another person that works, Miss Henson. She works and she watches the videos. So with that being said, 5.6 is scientific notation. Now, before we even start, if I asked y'all to give me a definition of scientific notation, most of y'all would say, well, it's the way that you write those big numbers and small numbers with 10 to the exponent. Y'all would say something like that, okay? That's not the definition I want. The definition I want is a Hubert definition. Placing the decimal to the right, I can't spell, to the right of the first number greater than or equal to 1. Or you could say, yeah, greater than or equal to 1. That's the Hubertism definition. Pretty sweet and to the point. Short and sweet. Now, let me go ahead and tell you this. 90% of the people that think they know how to do scientific notation, they do know how to do this. Like if I give you a BA number, 225,000. Okay? That's how much money I got in the bank right now. I wish. Okay? That's a big number. Where is the first number greater than 0? I meant greater than or equal to 1. Well, the first number greater than or equal to 1 is 2. How do you know that? Because which way do we read? Left to right. That's your first number, so the decimal needs to go there. The decimal right now on a whole number is right there. So you move it. 1, 2, 3, 4, 5. So then you write 2.25 times 10 to the blank 5. Now I'm showing you how to do this because I'm showing you from the, I've always sucked at scientific notation view, okay? 90% of the people that get scientific notation wrong, they don't get this wrong. They get the sign wrong. Okay, I'm going to show you another one. 0.00014. That's a very big number. That's a very small number. First number that's 1 or better. So I got to move that decimal right there. 1, 2, 3, 4, 5. So now it's 1.4 times 10 blank 5. And now you ask yourself one mental question. I'm going to put this in red, and I don't write in red, but I'm going to put it in red because it's mental. Mentally, I want somebody to tell me what mentally stands for. What is mentally? What does mentally mean?
Priority 1 message coming in on
Like
your channel.
In your head. Which means that I'm not doing it on paper. Let me turn my... I think, nope, that's the wrong one. There. I don't know who that was, but chances are it's probably my daughter. She's one of these people that like texts you 5 times when she's coming to see you or she's leaving. Mentally, ask yourself, which way do I move the decimal in my head to get the original form? This is the original form. So here's my decimal. Which way do I move that decimal to get it back to the way it was? To the right. So that's a positive. Which way do I move this decimal in my head to get it back to the way it was? To the left. And that's a negative. And that's how I teach scientific notation. Now, 90% of you, probably 99% of you, I never heard of that before. I've always taught if it's a big number, it's going to be a positive, and if it's a negative, it's a little number, it's going to be a negative. Well, that's fine, but when we get to adding and subtracting, multiplying and dividing, that's going to be a problem because you don't know which way to move it. Okay? Then that's where people get these wrong. People don't get these type questions wrong. People get these right. Okay? But that's not all scientific notation. And remember, I'm trying to discourage you and get you to quit. So I'm going to show you all the ways that you don't know to try to get you to quit. All right? So everybody knows how to do this. And that's your answer, 2.25 times 10 to the 5th and 1.4 times 10 to the negative 5th. So let's do another one. Let's do it the other way. Let's do 3.14 times 10 to the 8th and 1.31 times 10 to the negative 6th. Now here, you're given scientific notation and you need to write the answer in regular notation. So the first thing you do is you write 3.14 right there. And this is a positive. So that means I got to move the decimal to the right 8 times. 1, 2, 3, 4, 5, 6, 7, 8. And that's a whole number. So 314 million. I'm sorry, I've got the virus. All right, next. Rewrite. 1, 2, 3, 4, 5, 6. And that's going to be a decimal because your numbers are after the decimal point. Tens, hundredth, thousandths, 10,000th, 100,000th, millionth, 10 millionth, 100 millionth. So you're talking about 1/3100 millionths. Very small. Okay, so there's 4 test questions right there. And I'm going to tell you a little secret. Most of the time, those 4 test questions right there, and I'll highlight them because I want you to understand the difference between the easy scientific notations questions and the more difficult. Okay, so there is 2, and there is 2 more. And those are on my test, and they're on standardized tests. So I'm not, if you've got questions on this, then that's fine. Send me a question and I'll be glad to do it. But I can tell you right now from past experience, most of y'all know how to do these 4 questions. Okay? And if you don't, send it to me and I'll go over them. So which one's the ones you don't know how to do? Well, that's the addition, subtraction, multiplying, and dividing. Addition and subtraction is pretty simple. Addition and subtraction of scientific notation is basically like combining like terms. Okay, and you can go onto Google and you can type in adding and subtracting scientific notation. And rules, if you want to. And you can hit images. And they give you some rules right here. And notice, what's the word right there? I'll pull up this yellow one. Exponents are what? The same. Most of the time, okay, listen, most of the time when you are adding and subtracting, the exponents are going to be the same. Okay? I'm going to get off of that one. Let me get off of that one. Let's see. Where is the one where they're different? Because, well, I guess I don't have one where it's different. When it's different, you basically have to, well, they usually have one that's different. And I don't see it. I must not have pulled it up right. Here we go. Adding and subtracting when the exponents are different. If they are different, you must move the decimal so that they will have the same exponent, or you can write them in regular notation. Okay? So with that being said, you can go to the internet and print those 2 things out. I don't know if they're in your book because I don't know. I'm teaching you more. I'm not teaching out of the book here. I'm teaching what you need to know for future tests versus what's in the book. Okay? So I'm kind of going off on a tangent here. All right. So with that being said, if I have the exponents have to be the same. That's what I just said right here. So if I give you 2.0 times 10 to the 5th plus 3.0 times 10 to the 6th, I'm sorry, to the 5th, then all you do is bring this down, like 2x plus 2x is 4x. You just bring that down and you get that answer. So it's like combining like terms. 2x plus 3x, the x just comes down and you get 5. So it's just like you're doing combining like terms. But let me show you where students get the wrong answer. Here is an example, and I'm going to do it in red. That means you need to highlight it. Here is where you're going to go wrong. 24 times 10 to the 5th plus 6 times 10 to the 5th. Bring that down. 10 to the 5th, 30.0. Now, why do students get this wrong? This is when y'all need to talk to me. Why is that one wrong? Okay, I'm just going to sit here and get drunk while y'all tell me what the answer
Is it something with the place value?
Something with the what?
The place value?
You're right. What is the definition of scientific notation? Well,
Placing the
you
decimal
told
to the
us,
right.
Hubert. Exactly. Let's go back here. I'm going to do origami here. Hold on. Dang old origami, dang old folding up paper. Give me a second. I'm not no origami specialist. I do good with planes. When I made paper planes, when I should have been studying in school, but none of y'all ever did any of that. Placing the decimal to the right of the first number greater than or equal to 1. Where's that decimal? It's 2 places to the right. This is not scientific notation. So what do you have to do? You have to change it to scientific notation. So I'm going to move it 1 place. Notice I didn't say anything about direction. 3.0 times 10 to the 5th blank 1. Which way do I move this decimal in my head to get it back to the way it was? To the right. And your answer, your final answer, is 3.0 times 10 to the 6th. And that's how you do a problem like that when you have an answer that's not in scientific notation. And I can tell you right now that 90% of the people that get things wrong in this section, it's because of this step right here. They either leave it like this, or they change it, but they get a 4 here instead of a 5 or 6. And this one is correct. 6 is correct.
So when you move the decimal, that's where that 1 came from?
Yes.
Okay.
I moved to that black little hump right there. That black hump is represented by that blank 1. Okay. And then I go, which way in my head do I move this decimal to get it back to this, to the right? I got to move that decimal in my head to the right to get it back like this. So that's positive. Okay. Now, a lot of people say, well, I've never seen that before. I guess you haven't, because I came up with it when I was a student. I actually showed it to one of my professors, and they, of course, one of my professors, they were snooty, and they said, well, yeah, I guess you could use that. So they were kind of snooty. I would come up with these layman's terms of explaining things and say, can you explain it like this? And they'd go, well, yeah, you could if you wanted to. So it wasn't sophisticated enough for them. So that's how you combine, that's how you subtract. Now, if you have a subtraction symbol, then you would say 2 minus 3. Okay, of course, most of the scientific notations are not going to come out negative. It would be 3 minus 2, and you would get a 1 there. Okay, and you would just bring the 10 to the 5th down. So let's do one with subtraction, just so you'll have it in your notebook, in your handy dandy notebook. 5.0 times 10 to the 3rd minus 3.0 times 10 to the 2nd. I'm sorry, to the 3rd. And you bring that down, 10 to the 3rd. And 5 minus 3 is 2. Now, the funny part about this is a lot of people don't even realize what they're doing. You just took 5,000, 1, 2, 3, and you just subtracted 3,000. Now, a lot of people say, well, I could do that in my head. Well, yeah, you could, but what if it was real big numbers and you were multiplying or dividing? Yeah, then it gets a little bit hairy when you multiply and divide. This, yeah, that's real simple. Yeah, it is simple. But if you did 30.0 times 10 to the third minus 4.0 times 10 to the third, then you would get 10 to the third times, and then you would get a 26, and then you need to move that decimal one place and to the right, so your final answer is 2.6 times 10 to the fourth. Then you could say 30,000 minus 4,000 is 26,000, which is 1, 2, 3, 4. 2.6 times 10 to the fourth. So that's how you add and subtract. Now again, I don't know how many of you can or can't do this, but as far as difficulty, these four types of questions, okay, so far I've up to 4 questions now. I can't find them. Did I fold it? Yeah, I folded it up. You still got, get my origami going here. There's 4 questions. And now you got 2 more questions, which is addition or subtraction. And again, that's not what I'm worried about. So let's get to what I'm worried about. And that is multiplying and dividing. That's what I'm going to test you on. So with multiplication and division of scientific notation, you've got to remember add / subtract the what? Because the bases are the same. Exponents. Exponents. I can't write when I'm running out of page. Okay? You've got to remember to add and subtract the exponents. Somebody asked a question. Hold on. I'll see a chat. See if they asked a question. Oh, okay. It's not sure. What are you not sure about? Anybody? Was that answering a question or something?
I think that was something earlier.
Yeah, that was a while back.
Oh, okay. Do you okay? You get it answered or what?
Yeah, I got it.
Okay. All right. So, and the reason, I don't know if you know this, I'll show you why. When I first set up class, I'm in enrollment mode right there. And sometimes I forget to put it in chat mode. I got to get used to doing that. I wish they had something over here that when somebody asks a question, it like highlighted, but that's why I tell you students to use your hand. And that way, when you hit your hand, it comes up on the enrollment, and then I know, and I know there's a question. But anyway, I'll try to switch it to chat so I don't miss any questions. Okay, so let me put that back. All right, so here we go. Let's go with 2.0 times 10 to the fifth times 3.0 times 10 to the third. Okay, this one is not a difficult problem. It's not one that I'm worried about you missing, because I'm going to build up to those. So you just take 3 times 2, that's 6, times 10 to the 5 plus 3. Because what are the bases? The bases are the same, and the product rule of exponents say that if your base is the same and you're multiplying, which we are multiplying, then what do you do to the exponents? You add them. So our final answer is 6.0 times 10 to the what? 8. Now, that's not a problem that not a lot of students miss. I'm not worried about that. Let me show you the ones that you will miss. 3.0. Let me do this one in red. 3.0 times 10 to the 4th multiplied by 7.0 times 10 to the 5th. And again, it's not a problem until you get to those last couple of steps. And of course, at this point, the answer is not correct because you've got to move this decimal one place. And that's going to be 2.1 times 10 to the 12 blank 1. Which way do we move this decimal in our head to get it back the way it was? And that would be a plus. So your final answer is 2.1 times 10 to the 13th power.
Is that exponent of 4 and 5?
Oh, I'm sorry. I don't know where I got 7. Okay, let's just change this to a 7. How about that?
Okay.
I don't know how. I guess my medication don't kick in on my dyslexia, which I do have it. Okay, so sometimes I do write something. I don't know where I came up with that 7. Maybe it was because I was thinking of that 7 right there. I have no idea where that 4 turned into a 7. I have no idea. Sorry about that. Take pity on me. I have issues. Everybody has issues, except for those perfect people. Have you ever met a perfect person? Miss Hatton, I know you've met at least one perfect person in your life.
No, I have not.
Oh, listen, I have met them. I have met several people that thought they were perfect.
Yeah, that's the thing. Thought.
Oh yeah, and you know what? Most of them, no offense, guys, most of them are males that think they're perfect.
Now I know a lot of those.
Yep. All right, so here we go. Let's do a nerd. Let's do 25 times 10 to the 3rd. I'm going to let y'all do this one. Times 4 times 10 to the 5th. All right, I'm going to let y'all do that one. Of course, I think everybody in here knows what 25 times 4 is, and that's the whole point. I'm not worried about you being able to multiply 25 times 4. That's not what I'm testing you on. I'm testing you on your final answer. So I'm going to give y'all a minute. I figure a minute is enough time to discourage you. What do y'all think? I think I've figured out how I can make the stock market go up. Y'all know how to make the stock market go up? I'm
How?
going to sell my stocks. And when I sell my stocks, the next day the stock market's going to go up. I'm getting tired of checking my stocks. I'm about ready to quit checking them. Damn Russians.
Always messing up everything.
It's the Russians' fault. When stuff don't go your way, you blame the Russians. So I'm gonna blame the Russians that, you know, my stocks are going down. All right, so here we go. 25 times 4 is 100. That's 100 with a T. Now, if you're not from around here, you say 100. Okay? But I say 100. Kind of like Belton. Belton don't have a T in it unless you're not from there. And if you're not from Belton, it's Belton. I'm from Belton. And then Powdersville. Y'all have no idea what I'm talking about. But anyway, times 10 to the 3 plus 5. So 100 times 10 to the 8. Uno, dos, 1.0 times 10 to the 8 blank 2. Which way in my head do I move this decimal to get it back to look like this? To the right. So our final answer is 1.0 times 10 to the 10th power, or 1.0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Thousand, million, billion, 10 billion. You just took 25,000. You just took 25,000, I think. Hold on. No. You just took 2,500 and you multiplied it times 400,000. You took 2,500 and you multiplied it by 400,000, and you did it technically in a couple of lines because there's a couple of these you don't have to do. And you got
I
100
think you
or
were right
10.
at 25,000.
I'm sorry, what?
I think you were right at 25,000.
Yeah, I was. Yeah, because the decimal's right there. 25,000. Sorry about that. 25,000 times 400,000. And they ain't nobody in this room, and I'm included because I'm in the room with you. They ain't nobody in this room that can do that in their head. But you did it in a couple of steps with scientific notation. That's the reason for scientific notation. So you can take 25,000 and multiply it by 400,000 and get a nice answer without having to utilize a calculator. I'll tell y'all a story. I had a student, and bless her heart, she was trying. And I put this, something like this on a test. I said, okay, I want y'all to do a problem like this. And this poor girl, she did this. And she proceeded to do this right here. And luckily I came by. She was about, let's see, this, and then you got this one, and then you got this one, and then you got this one. She was about the third row of X's. You know, when you move everything over 3 places, she was about there, and all these zeros out here. She was going to it. I don't want you to miss the point. The reason we have scientific notation is so you can work, with or BA or SA numbers. Okay? That's why we have scientific notation. We don't have scientific notation because somebody thought of it as a way to get on your nerves in math class. That's not what it was. It was developed so people could multiply and divide, especially multiply and divide, BA numbers or SA numbers. And that's what it's for. So please, don't be this person that I'm sitting telling you how to use scientific notation, and then you go off and do this. This is called missing the boat and the train. If you sit through 30, 45 minutes of me talking about scientific notation, and then you do this. Okay? Don't do that. Anyway, that was a long, long time ago, and hopefully none of y'all did this. Okay? But I guarantee you somebody out there has had scientific notation in the past, and you were totally confused. And hopefully I'm not confusing you. Now, if you've had success with scientific notation and you do your own way, and you got this answer right here, and you got this answer right here, if it ain't broke, don't what?
Don't fix it.
Don't fix it. Your parents did well, Mr. Brickman. If it ain't broke, you don't fix it. Okay, I'm having a cat fight. Okay, y'all finished? All right. If you are not having problems with it, you keep doing what you're doing. I got to say that because I sure as heck don't want to confuse anybody. All right, let's do division. So 21.0 times 10 to the fourth divided by, that one's dead. Hold on. Moving over to the trash can. I have to throw away my markers because I've got so many markers around my computer right here that I have to throw them away, because if I don't, I'll keep using dead markers. Divided by 3.0 times 10 to the first. Now again, 21 divided by 3 is 7 times 10 to the 4 minus 1. You subtract the exponents because these two are the same basis, and that's 10 to the third. Not worried about that one because most of you will get this one right. Versus 45 times 10 to the third over 3.0 times 10 to the second. Now, let me go ahead and say this. A lot of people say, well, Hubert, I'm good at scientific notation. Why can't you just change 45 times 10 to the third to 4.5 times 10 to the fourth? You can if you want to. I don't care when you do it, but you have to change it. Okay, and then you get 4.5 divided by 3. And most people, when you see 4.5 divided by 3, even though you do 45 divided by 3 is 15, you will reach for a calculator to do 4.5 divided by 3. So that's why I don't show it that way, because some people, when they see a decimal, they'll reach for a calculator. Even though they know 45 divided by 3 is 15, they don't relate it to 4.5 divided by 3 is 1.5. So, you know, that's another issue there. But I just go ahead and just tell people to do it and then change it at the end. So here I've got 15 times 10 to the first. I need to move it one place. So that's 1.5 times 10 to the 1 blank 1. I need to move that to the right to get it back like this. So that's going to be a positive. So 1.5 times 10 to the second. Now that concludes scientific notation. But What will I put on a test? I'm going to show you what I'm going to put on the test. Remember, what's my job? To get y'all to what? Quit, right? So this is what I do. I don't give you all those basic problems. I give you some that will make you what? Skip the problem and not do it. So, y'all know I'm kidding, right? I hope you do. Please don't. Well, they're used. My bosses are used to it, so they won't say nothing. Anyway, let's go to. I'm gonna go to. I'm not in charge of 155, and I could add these, but it's easier for me to get y'all to go to the chapter contents and go to 5.6. And I might add some. I might add a 5.6 homework because I want to make sure y'all. Okay, I don't know where am I at? What is it doing? I don't know what this thing's doing. Them Russians have taken over my lab plus. Let me go to chapter contents, chapter 5. There. Now, why didn't they do that before? I know why. It's a conspiracy. Study plan. Study plan. I'm about ready to quit. There we go. And I'll go to the last 5 or 6. Nah. I want to get to the ones that's going to make you quit. What the heck? Well, that's not right. Okay, I must have hit a number that I didn't. These are all test questions. That's not the ones I'm looking for. There we go. What do we all refer to when we want to get discouraged, students discouraged? We go to what? Word problems.
Yes.
Yeah, there we go. Now I'm getting some interaction from y'all. In June, the population of a large country was 307 million. And the population of the world was 600 whatever. Determine the ratio of countries' population to the world's population by dividing the country's population by the world's population. So it tells you what to do. All you got to do is do it. Yeah, these are the questions. What I might call it is 5.6 word problems. And I might go in and give y'all some of these word problems because I don't want you to feel too confident with doing the other problems. I want you to, feel discouraged somewhere down the line. All right, so here we go. Let's go with 6.83 billion. Well, that's 6,830 what? Million. Divided by, or that's divided by into, or divided into 307 million 200 what? Thousand. So here is what I'm sorry, hold on. Here is what we're doing. That's what we're doing right there. Now, do you have to do that or can you simplify it anymore? Somebody tell me if you can simplify this problem before using scientific notation. Yes or no? You got a 50-50 shot.
Yes.
Tell us, Mr. Bustos, what can you do to simplify this problem, excuse me, without scientific notation?
Without scientific notation?
Yeah. What can I do to simplify this before we get started without scientific notation?
Scientific notation was my answer.
Okay, you can do it with scientific notation, but there's one other thing you could do before we get started. Does anybody want to try to answer it? What do you do with zeros if you have the same amount of zeros? What did I just do?
Crossed them out.
I just canceled them out. Now I can do 3,072 divided by 68,300. Y'all make sure I copied that down right. I'll tell y'all something. If you punch this in a calculator and you punch this in a calculator, what will you get? You'll get the same number. Now I can change this to 3.072 times 10 to the third divided by 6.83 times 10 to the what? 1, 2, 3, 4. And of course, you're going to do this in your calculator because I don't have any idea what that is. I'm not Rain Man. But what's 3 minus 4? 10 to the negative 1. Somebody give me this. Somebody give me 4 decimal places. What's 3.072 divided by 6.83? And I need to finish soon because some of y'all are going to start convulsing. Somebody give me that number. 4 decimal places, please. Okay, I'll do it. Appreciate the interaction, y'all. Y'all done quit for today. 3.072. Even my helper, Miss Hatton, won't even talk to me. Divided by 68,300. Oops, I'm sorry. I did the wrong one. 3.072 divided by 6.83. 0.44978 ... What's wrong with that picture? That's not in what? It's not in scientific notation. It needs to go right there. So that's 4.497803807 times 10 to the negative 1 blank 1. I'm sorry. Okay, and which way did I move this decimal to get it back to the way it was? To the what? To the left. So that's going to be 4.497803807 times 10 to the negative 2. And that should be your answer. Now, I don't know if they want it in scientific, but I'm going to put it in regular. 12.04497803.807. Now, I'm going to do one more thing before we leave. I'm going to take 307, 200,123 and divide it by 6 million or 6,830,000,000. 1, 2, 3, 4, 5, 6. It's a miracle. 0.04 and I got 0.04. Look at there. Isn't that a miracle? And I got 80381. They rounded, the calculator rounded the last digit. Isn't that a miracle? So let's see how many questions you got in that section. I'm just looking. 34, that's 34. 1, 2, 3, 4. There's 4, 5. There's 5 there. I can't add that because I know, no, I haven't given y'all this homework yet. So I can add that. Good. I'll just do that right now. And that way y'all can see it. Hold on just a second. And y'all can see it, and I don't need to call the roll, so we'll be through in just a second. I'm gonna go ahead. Oh, have I assigned it? Shoot, I have assigned it, so I won't be able to go in and change it. Let me see if I can. Nope, somebody's already started it. So I'm gonna call it. I'm gonna go in and I'm gonna create assignment. And I'm going to create a homework assignment, and I'm going to call it 5.6 Word. I'm just going to put Word and next, and 5.6. Just hold on a minute. You're not going to die. All the objectives, I'll just go down to the word problems. It's the last ones. And I think it's these right here. Word. There it is. 1, 2, 3, 4, 5. And 1 right there. Add it for good luck. And I might do it again. 1, 2, 3, 4, 5, 6. And that'll give y'all. And I want it today. What's today? Today is the 4th and 8 o'clock. I always do it 8 o'clock. I do everything the same. And save and assign. So now you have 2 homework problems, and I got to move this down here. 5.6 Word. And then we're going to go over 10.1 next week. So right now, every one of you should be working on 5.6 homework this weekend. And it's 5.6 Word. That's what y'all should be working on this weekend because that's what I expect questions on Wednesday when y'all come back. Okay? Any questions for me? I'm going to shut off the recording. Any questions for me?